Promises in JavaScript are a great way to avoid callback hell and create a lot of cool interactions with your website users. And to help you with that, in this video we'll be covering what are promises and why you should use them, how to create a promise, and some real examples, so by the end of this video you will absolutely understand promises. So, without further ado, let's get straight into the video. Promises are used to make websites more dynamic and user-friendly. They allow you to fetch data from a server without really blocking the main thread of execution, which means your website won't freeze while waiting for the data to arrive. One example in which the main thread is blocked and the website freezes is when you accidentally create an infinite loop, and the only way out is by shutting down the website. But instead, the user can still interact with the website while the data is being fetched. And once the data is ready, it will be displayed on the website, or something will happen, that's for sure. In order to create a promise, there are a couple of things you should have in mind. First, create a variable that is an object of the class promise. The constructor of the class promise needs to receive a callback function that has two parameters, the resolve, or success, and reject, or error. Inside the callback function, you can use the resolve parameter to return a successful result, or the reject parameter to return an error. The resolve and reject parameters act like a return statement, which will terminate the function. And you can also add arguments into the resolve or the reject in order to specify even further the type of resolve or rejection. Another thing that is also really important when creating promises is the resolve and reject. Yes, you probably didn't understand. Resolve and reject act like a return statement. And because of that, you can only have one per each condition path. So, make sure to make the most appropriate conditions in order to resolve or reject as best as you can when creating your promises. Now, in order to use a promise, the same scheme will be used. Firstly, use a variable that is a promise object. Then, write dot and then, as if you would call a property of an object called then. That then receives a callback function, and that function should receive a result as a parameter, or some any other name, but it's going to basically be something that you are going to send through the resolve, and should somehow handle the fulfillment of the promise, like console log or something like that. And while the then handles the resolve, the catch handles the reject. Apart from that, the catch is basically the same thing as the then. For those of you that didn't really understand how you reject or resolve a promise, I'm going to go a little bit slower on the condition part. The response object was created to simulate something from the database. In the case that we find an error property within that object, it's because we need to handle the error. And we have that condition that verifies if you have an error property in your object. If you don't have it, you are going to resolve the object. And if you actually have an error, you are going to reject the object. Later, when handling the promise, you can either show the error or the value, depending if it is a resolve or a reject. This is the logic that I used for this promise. But you can use any logic that you want, it depends on your application and your requirements. But one thing is for sure, when you have a success, use the resolve. And when you find a problem, use the reject. The use of the catch can be excluded, since the then function can also receive one callback function to handle one rejection. You can also create named functions in order to make things even tidier. However, such should only be done when you intend to use that function in more places, so you don't waste memory and such. Now, let's get to the real-world examples. In this first example, we will be fetching a joke from an API and consider it a success if the joke is of the type programming. We'll be using this API right here, the official joke API, which will return a joke, but in this case a random joke, only one joke, to make that condition of the programming joke. And now the first thing you need to do is store that URL as a string in a variable. Then we also create a function, because we could create an object of the class promise and use it every time we want to get a joke. But then we would need multiple objects, and the best way to create multiple objects like we want them to is by creating a function that returns that object. Then we are going to return the new promise object, of course, and put the two parameters, the reject and the resolve. we could use only the resolve. However, in this case, we are going to need a reject, so let's put the two of them. Then, we are going to fetch from the URL. And don't get confused, since a lot of asynchronous functionalities in JavaScript uses the then and the catch keywords as well, just as a fetch, because the fetch will also use then and catch to handle its information. But since the fetch is not really the point of this video, we are going to ignore that specific part for now. And inside of the first then, the fetch is basically receiving a JSON string and converting it to a JavaScript object. And since it is now a JavaScript object and not simply a JSON string response, now we've named it joke. And you can access it like a JavaScript object. You can put joke.type. Well, it depends on the object, but this object has a type property, so we can access the property and verify if it is programming or not. If it is, we are going to resolve the joke just as it is. If it is not, we are going to reject with the new error, which is basically an instance of the class error of JavaScript, and we are going to send a message: joke is not a programming joke. And then that last catch, right down there, is not actually for any type of promise handling, but for the fetch still. Because if the fetch can't really fetch by some reason, what is going to happen is we are going to reject the promise with the error that we got from the fetch. This is a great example to show you guys that you should always try to reject as many possible errors as possible when working with promises, which will allow you to prevent app crashes and unexpected behaviors. Now, since you already have a function to create a promise, we should also have a function that will basically handle it. We could handle it outside of a function, but if the function already calls the getJoke and handles the promise, it's the better. The only thing that we need to do in this log joke is basically, if we find the resolve, show the joke, or just console log in this case, and if you find an error, just console log the error. With the function created, the only thing left is to test it out. And to test it, we just need to execute it, either in the console or in our code. But we just need to execute it a bunch of times, because there are more not programming jokes than programming jokes in this API. And when we finally find it, instead of having the error that joke is not a programming joke, we will receive everything inside of the joke object. You should already know that promises are asynchronous, and because of that, they do not happen instantly. You ask them to make something, they do their thing, and when they are fulfilled, they either resolve or reject. This much is pretty simple. Now, it's time for an exercise. If I put a console log, the joke, and another console log, which order do you think is going to show up in the console? Console log, joke, console log? Or two console logs and a joke? Since you already know how asynchronous code works, doesn't go straight into the main thread of execution, it is going to do its thing, and only when it is finished, it is going to show up, to be displayed or do anything else. And since it takes a little bit more time to request data from an API and receive it than just console logging it, it's pretty obvious that the console logs are always going to be first. For our second example, we'll be making a conversion between callback hell and the promise-based code. In this example, we are basically managing a message system for pizzas, in which we prepare the pizza, cook the pizza, deliver the pizza, and all of that stuff. And when a step finishes, we want to send the next step. But by using callback functions, we are going to send callback after callback after callback. And after a lot of callbacks, the code is going to become unreadable. And we don't want that. A really way better approach is going to be using a promise-based code, in which we work with promises, we choose what we want to send through the resolve or reject, and when we want to call the list of functions that need to be executed one right after the other, we just use promises to do that. Right before converting anything at all, I'll be showing you guys what is going to happen if I order a pizza. The first conversion that is going to be made is going to be basically the first function, since all of the functions, except the last one, are basically the same. If you want to work with promises in a function, you usually want to return a promise object. And with that promise object, you usually want to put inside everything. In this case, you can either put everything inside of it, or if you want to make something instant, you can leave it outside, like we've just done here. You already know how to create your promises. But the second step for the conversion is basically removing any dependency to the callback. You need to remove the callback from the arguments on the top, and also don't execute the callback down there. Instead of executing a callback, you are going to either resolve or reject. In this case, we are fulfilling because it's on messages. So the only thing we need to do is to resolve it, and put the parentheses of course, so we execute the resolve. And that way, if you do the same thing with all of the rest of the functions that you want to chain together, it's going to work just fine. For the last function, which is going to basically be the father of all functions, the one that is going to call all of them. To order a pizza, we are going to basically remove everything that's inside, because I don't want it, and we are going to create a new function. That new function is going to execute the first function of the multiple functions that you want to execute, probably the prepare pizza for our example. Then you just need to execute it, the chainable then, instead of the parentheses of the then, you just need to put the callback function, a function that you are not going to execute, you just put it together, and then you just repeat. So you put the put in oven and then you put the deliver pizza. Now there are only two things left. To order the pizza, which is going to be run right now, we are going to order it right now and eat it. And one more thing. In JavaScript, in the promises, the last then can also be switched to a finally. That way, showing to everyone that delivering the pizza is the final function. And obviously, as you saw in the background, we could order a pizza just as fine with the promises as we could do with the callback hell. And this piece of code is way more readable. And if you are slightly confused about those arrow functions and those callback functions that we so much talk about, make sure to watch the video Functions Inside Functions Explained Easy. It is basically about callback functions and different ways that you can write functions. If you are interested, make sure to check it out. Almost reaching the end of the video. There are 3 extra tips for promises in JavaScript. Being the first one, the concurrency. The promise class offers some pretty useful static methods for you to use, and I'm going to talk about the 3 most important ones. Promise.all returns an array with all of the resolve values. But if anything rejects, the rejection is the only answer. Too bad. Promise.race is quite the opposite. When the first one is fulfilled, it will resolve or reject. Depends on the winner of the race. And of course, with a value of that said fulfillment, the first one. While the promise.all salad is pretty much like the all, but returns a whole array of objects with a correspondent status. Instead of, oh, if someone rejects, it's rejected. No. It's an array with all of the objects with rejections and fulfillments. The second tip I have to give you guys is about errors. Promises can be rejected for various reasons. Some you know, and some others you really don't know, and it is the console log that is saying, oh, there's a rejection that is not being handled. How do we do that? And for that reason, you should always try to catch as many rejections as possible. That way, avoiding unexpected behaviors and potentially avoiding your application to be crashed. And the last tip of all is that by chaining promises together, you will avoid all the callback hells you have in your project. So don't forget to use promises. Do not start the callback hell. If you think, when this finishes, I want this to happen, okay, you can use the callback that time. But if you see, oh, but if I send a callback, then a callback, then a callback, no. Starting from the 3, you should always consider using promises or any other way of asynchronous stuff, because if you go that way, there might not be a way back. Promises have a really good browser support. According to caniuse.com, promises are supported by most modern browsers, including Chrome, Firefox, Safari, Opera and Edge. And of course, Internet Explorer must be excluded from that list, since it doesn't really get support from anything nowadays. And this, guys, is pretty much everything you need to know about promises in JavaScript. However, if you still want to learn more about callbacks and arrow functions, make sure to look at Functions Inside Functions Explained Easy. That way understanding how functions work in a nutshell. And finally, thank you for watching this video until here. If you still have any doubts, leave a comment that will help you out. I'm Diogo Veigas and I'll see you in the next video.